So, reactions of alkenes with potassium permanganate. This is something I did not realize until I started looking up background information for this video, and never saw this in your book for some odd reason. I have 2 editions of Carry now, and they never talk about this. What they do present is the reaction of potassium permanganate with an alkene, and what it will do at low temperatures and low concentration, which the book did not bother to specify, is that it will form a diol. Now, this addition of the diol is a syn addition. So if we do end up forming stereocenters, our alcohols here are going to be on the same side, added to the same side of the bond. So, potassium permanganate, low temperature, low concentration will give you the diol. Let's say we go to moderate or high temperatures in high concentrations. Well, this is actually going to look really similar to ozonolysis. So what's going to happen is the potassium permanganate is going to further oxidize this bond. So if we have, again, our alkene, high temp, high concentration versus low temp, low concentration, we actually end up splitting this bond entirely, and what we will produce in this case are the ketones. Now, if for whatever reason one of these groups was a hydrogen, we produce a ketone and alcohol. If one of these groups over here was an H group, we produce 2 aldehydes. The thing is that this is going to act a lot like ozonolysis. So our potassium permanganate has 2 options for us. If we are at low temperatures, we'll end up getting the diols or the glycols, and if we go to high temperatures, high concentrations, we produce the ketones and aldehydes similar to ozonolysis. So if you were looking to produce ketones and alcohols and ketones and aldehydes, you don't have an ozone generator, this is a viable option. But again, you can go to low temperatures and get the glycols as well.